Hello dear students. In the previous class, you are studied about the some of the basics regarding your subject for system analysis 2, where you come across the terms like graph, subgraph, oriented graph, tree, co-tree, branch, element, many things you are studied. Today, we will see the incidence matrix, and also it is the basics of your graph theory only. So we will see in details of what is incidence matrix as well as what is bus incidence matrix. Yeah, what is incidence matrix? It's nothing but element to node matrix. Usually it is denoted by A cap. Element to node matrix means order of the matrix is taken as E cross N. Means in rows we are going to take the elements and in columns we are going to take the nodes. Say if one graph is having 6 elements and 4 nodes, then order of that particular incidence matrix is 6 cross 4. The incidence of the branches to nodes in a connected graph is given by the element node incidence matrix. How to write this A cap or incidence matrix A? Let us consider Aij, means it's an element of that particular matrix where ith element to jth node. Means if particular element Aij is considered as 1, means the particular branch I or the element I is incident to a node j and oriented away from that particular node. That time you have to take it as 1. If the particular Aij is taken as -1, means the particular branch or the element I is incident to node j but it is orient towards it. Means in this incidence matrix we can consider as if a branch or element is incident with any branch, any node, you have to take it as 1. If it is going out from the particular node, then you have to take it as 1 or positive 1, and if it is coming towards the particular node, that time you have to take it as -1. If the branch or the element is not at all connected or not at all incident with the node, that element you can take it as 0. So let us see these things with a example. So this tree we are going to see in the previous class. You are come across this tree and you are drawn this tree from the single line diagram. So in this network or in this graph, we are having 6 elements and 4 nodes including one reference node. So that reference node is taken as 0 and remaining nodes are 1, 2, 3. You can see in the figure. So element 1, 2, 3 are connected to ground node and 4, 5, 6 are connected between the other nodes. So how to draw the or how to write the incidence matrix or A cap matrix for this particular graph? See here, I have written here matrix of order 6 cross 4. You can see here in the right side element wise it is 1, 2, 3, 4, 5, 6, and in nodes wise there is 0, 1, 2, 3. There are 4 nodes, and in the previous class only I told there are branches and links. Totally, the sum of branches as well as links together we are calling it as elements. How we are going to decide the elements as branch and links? Obviously, how many number of nodes excluding reference node, that many number of branches was present, and remaining all we are consider it as links. So we will write the incidence matrix here. See here, element 1, you can see where it is connected from the 0 node to node 1. It is connected. You can see it in clearly in the picture. See where element 1 is connected from 0 to 1 and direction is from 0 to 1. How to write this one? You see here, element 1, it is connected from 0. So element 1 with 0 is 1 and going towards 1. you have taken it as minus 1. 2 and 3, it is not at all incident. You can see here, element 1 is whether it is connected to 2 or 3. No, it is only connected to 0 and 1. So we can put it as 0. The same thing you can see here, element 2. Element 2 is connected between 0 to 2. So I have taken here 0 as 1 and 2 as minus 1. Remaining 1 and 3 we can take it as 0. Coming to the third element, where it is connected? It is connected to 0 to 3. See, third element we are considered it as 0 as 1 and 3 as minus 1. In between 1 and 2 it is 0. Going to the fourth element, it is connected between 1 to 2. See, direction is towards 2. So fourth one is 1 as 1 and 2 as minus 1. What about fifth element? See, it is connected between 2 and 3. Direction is towards 3. So you can see fifth element is from 2 to 3. 3 is taken as minus 1, 2 as plus 1. 0 and 1 nodes are taken as zeros. The last element, sixth one, is connected between 1 to 3 and direction is towards 3. So in sixth element we are taken it as 1 as 1 and third node as minus 1. Remaining the reference node as well as the second node is taken as 0. So this is what the incidence matrix. Now we can see the bus incidence matrix A. You can see the difference clearly. Incidence matrix is represented as A cap, and the bus incidence matrix, it is also called as reduced incidence matrix. It is represented by A. See how to get this bus incidence matrix or reduced incidence matrix. This is by selecting any one of the nodes of the connected graph as the reference node, and the corresponding column is deleted from A to obtain the bus incidence matrix. Means directly we can say that removing or removal of the reference node from the incidence matrix A cap is nothing but the bus incidence matrix. Means now the dimension of A is can be concluded as E into n minus 1. In the previous A cap, what we are seeing is E into n or E cross n, where E is the number of elements and n is the number of nodes. Here E cross n is element to number of nodes excluding the reference node. So here the order of the matrix is n minus 1. The same problem we can write the matrix A. You see here, the first column shows you the A cap or incidence matrix. The second column shows you the bus incidence or reduced incidence matrix. You can see here, first matrix is 6 cross 4 and the second matrix is 6 cross 3. So what we are done here, just we are removal of the 0th column or the reference node column is removed here. You can see that matrix clearly there. In the second matrix there is no reference node. So it is very easy to get the bus incidence matrix from the incidence matrix by removing the just a reference node. If a bus incidence matrix or reduced incidence matrix is directly given, how to get back the incidence matrix? That is also very simple. If you have to add one 0th column, and you have to add in that particular 0th column 0, 1 or minus 1, such that addition or sum of the particular row must be 0. Say here, you can see in the first row of the A matrix there is only 1. So you need to add a minus 1 to that particular element, or there is minus 1, so you need to add the 1. Coming to the second row, only minus 1 is there. In the 0th node you have to add 1, or in the third row minus 1 is there, so you need to add the positive 1 in the 0th node. Coming to the fourth row, 1 minus 1 is there, already sum is 0, there no need to add anything, so the element of the 0th node will be 0. Same thing will be there for 5th and 6th. There is no need to add anything, just 0 we can put. We will get back the A cap matrix. Okay, yes, let us go for this another example. We can see here, 4 bus system means here there are total 5 buses, because 1 2 3 4 4 buses we are shown and 4 generators are shown here. So we can conclude that if generators are shown there, another side of the generators are connected to ground, as in the previous class I told. So we have to consider there is a zeroth node is available and present. All the 4 generators, another part is connected to that particular zeroth node. From this single line diagram we need to get the graph first, then only we can go for the solution of this. See, this is what the graph or oriented graph from the given network. You can see, I told you, no, there are 5 nodes, 1 2 3 4 and another one is 0. There are 9 elements. You can see here in this figure, 4 generators. You can number it as 1 2 3 4 according to your buses. For number 1 bus, the connected generator, you can take it as number 1, and second generator is connected, which is to second bus, and third generator which is connected to third bus, and fourth generator is connected to fourth bus. Remaining 5 6 7 8 9 elements are shown here. Same thing I have drawn here. See here, excluding reference bus, there are 4 buses, so 4 branches and 5 links are shown in dotted line. In pink color we are shown the branches, where there are 4 branches are there, because there are 4 nodes. So here you can clearly see the differences from single line diagram to the oriented graph. You can see I will just show you. First element is generator 1, where it is connected from ground to node 1. See here, number 1 connected from ground to 1. Same thing second generator, where it is connected from the second from the ground to second bus. See here, the pink line, number 2 is connected between ground to second bus. Same thing third and fourth elements. And coming to the fifth sixth element, already it is shown from where to where. Same thing I have drawn here. Okay, so this is what the incidence and bus incidence matrix of the given network. So you can see the things where first element is connected from 0 to 1. How it will be? See, element 1 is from 1 to -1, because here for matrix A cap order is 9 cross 5, and for reduced incidence matrix order is 9 cross 4. See, for this particular figure, we have to write the A cap, then we have to remove the 0th node. We are going to get the reduced incidence matrix. So wherever the blank elements are there, means blank elements of matrix, you have to put it by 0. This is what the A cap as well as A. You can try this one by your own, by writing this graph, and you try to write this 2 matrix. Okay, with new other examples and other chapters. We will see it in the next video. Thank you.